I'm really excited to be talking about this today, and I think looking at the previous two presentations, this was originally the Lindquist PCT study, so it had specific management objectives early on for the commercial timber, but biology is biology, and I think this has segues into the other presentations we've seen previously. Some of the lessons from here can be applied to restoration orientation. So, Lindquist reported on this about 10 years ago. At that point, some of the trends weren't obvious, but so I'll go ahead and go over the site design. And we have a series of 3 blocks, and each block had 6 plots installed with a range of 100 to 300 trees per acre being left, and then an untreated control. And they were randomly assigned. Each plot, or each area had 0.4 acre treated, and then within then was a nested 1/5 acre plot. And it's been measured repeatedly. The neat thing is this was actually established in the footprint of the old Casper cutting trials, and so we have good records of this stand before of the second growth, before we transitioned to third growth. You can see the top photos are the characteristic of the stand at regeneration in the 60s, and then the lower photos are the lower diagrams are stem diagrams from plots. And what you'll see is on the right-hand side, the unthinned control. You can see the stem map actually shows the clumpy distribution that's consistent with what we see in Redwood natural regeneration. On the 200 tree per acre thinning, even though we tried, because we were thinning from below and retaining high vigor trees, it's in no way a 15 by 15 regular grid. So this makes the experiment interesting. It's our usual story of high variability can sneak in with our clumpy redwoods. We certainly had an easy to see trend though from establishment on. By thinning from below, we changed the diameter distribution for the average diameter of stems in each of the plots by treatment. And so redwood has remained significantly larger diameters throughout the study. Douglas fir, not so much. There's fewer. Right now there's smaller trees, and we've had more mortality in the Douglas fir as well. So they did not have significantly different results. The fact that this is a fairly easy to access area, we have a trail through it, it's been used for tours and educational events over the years, and the diameter distribution is really easy for folks to see. Most recently we had some Japanese forestry students go through this spring. Stand density index has remained significant through time as well, and so the stand density index has been increasing. The density is this is where things get kind of interesting, is the density sequence. You would expect the lowest density, the lowest number, and that's certainly true with the 100. But then the sequence goes 100, 200, 150, 300, 250, and then the control. So I think with the variability in the stand structure, some of those intermediate treatments may be overlapping each other some ways. This is where it gets even more foggy as we start getting into basal area. So this is averaging on a per acre basis. And we do not get significantly different results for the treatment at this point. So at this point, you kind of want to go back and think about what are we measuring? What do these plot data look like? And so this is what we've got. The green are the control, is a control plot, and you can see we've got a wide distribution there. Quite a few of the smaller diameter, and even in the 250 trees per acre, we still have a fair number of suppressed trees. If we're thinking about the future, we're thinking about which are going to be the canopy trees, which are going to be the trees that, say, depending on your trajectory, would be intermediate, a thinning. But how would you, what are the highest value? Which are the trees that are going to be most valuable for restoration measures? So chose 140 trees per acre as our target. This is what the distribution would look like laid out on those 2 plots. And then this is the data set when we analyze the 140 crop trees. So these 2 are the volumes, and you will see that those charts are volume for all the trees per acre through time, and we did not see significant differences when we tested statistically there. That's, aside from the fact that 100 generally is lower, that's about all you can really glean from that. But when we went to the focus on the focus trees, for cubic foot volume, we did find a significant difference with a NOVA test of cubic foot volume and also the block design. When we looked at board foot volume, which this stands kind of growing into the board foot zone, we just missed significance with the treatments for trees per acre, but we did see difference with blocks. And so thinking more about why is this stand, why are we trying to sort out these numbers, this is looking at species composition, and this is using stand density index. So this is actually, stand density index, in contrast to some of the other metrics, should tie more to how much growing space the trees are using, what's their biological demands on the site. And at this point, redwoods certainly comprise 80 to 91% if you look at the average. There's still a lot of variability. We have some plots with absolutely no Douglas fir, and we have some plots with 25% Doug fir. This is, I'm going to catch up on this because this is the analysis that Dr. Barrell did, Pascal, and he is unfortunately doing a presentation elsewhere, so I hope to do it justice. Here, this is not too scary though, because this is pretty much a standard site index. You've got the dominant tree height. We've got the 18 different plots, but by treatment, and you can see there's quite a span. There's quite a range of site quality we're getting by traditional site index. And you notice here that the 200 and 300 seem to have much lower site quality than the others. This is the so our vertical axis is staying the same. We're still talking about dominant height. But on the horizontal axis now, we've sorted out the plots by what their concentration of redwood is in terms of occupying growing space. So we have 100% down to one about 75%. And what we're seeing here is he actually found a correlation between the higher the redwood concentration, the higher the taller the height. So that's kind of interesting. This is where things get interesting because this is the other indice that Dr. Bell introduced or has worked on. This was actually, he was working nearby in Railroad Gulch, which is much more complex stand structure and much harder to find that dominant site tree. So here he's replaced on that axis, instead of height, he's got the basal area index, and this will have still the same horizontal axis of percentage. And you'll see we still have a correlation. It's a little different shape. And then this last slide goes back to the first one where we're looking at by treatment. We're seeing now the treatment and the basal area, redwood basal area index, we're actually seeing that the 200 and the 300 come back up. So what the technique he's using gets past the confounding factor of having multiple species having the Douglas fir in the mix. This is a slide I put together that shows the different types of site indexes that have been run over the years on this study, going back to Lindquist and Pauly's ones. I've also got the 2011, it was in Crumlin and Ing, but it's actually, I think, Wetzel and Crumlin site index, and that's a base age 50 and the stand's 49, so that's probably a pretty good match. And then the BAI index basal area index is there as well. One thing you can really say is that the north plot is consistently, no matter how you measure it, it's consistently been a higher site quality. And that's kind of an interesting thing because that plot is the same, almost the same. There's nothing really different except the early stand establishment history. That stand had been control burned, and it came back, according to Lindquist, heavy to cyanosis, and that tended to depress the amount of natural regen of Douglas fir, as well as damage some of the tops of the Douglas fir. So it's kind of interesting to think that maybe we're seeing an indication of something that happened 50 years ago. So our findings are the subtle differences in site quality and composition made it difficult to initially observe some results. We've still got a lot of work to do on trying to sort it out. Pascal's work found that there's that trade-off is going on right now between you may have more stems that are growing slowly versus fewer stems that are growing quickly. And then we can certainly say with the ANOVA test and the work that I worked on that pre-commercial thinning definitely enhanced average tree diameter through time. And now that we're looking at the 140 trees per acre, the crop trees, the focus trees, we also saw the basal area was significantly different, and that cubic foot volume was as well. So, the future is our next reentry, or next remeasurement interval will be 2021, so we're looking forward to that, doing it about a 10-year interval. We provided the data set to Dr. Barrow, and we'll happily share it with other folks we have in the past. This is an interesting stand at this point because it's gotten through stand establishment and it's starting to move into the area where other stands have traditionally been studied. So it'll be interesting we could probably validate some growth models, some other approaches by taking this stand and figuring out different ways it could go forward. I think we'll continue to keep this, at least in the short term, as a study plot here. The other thing that's going to be interesting is we have a second thinning study that's nearby that thinned, this thinned at 17 years, which is kind of operationally late. This one was, the other study that Dr. O'Hara is working on was thinned at 10 years, and it's on a variety of sites. So I think we can contrast these two studies and get some interesting information in the future. And I definitely want to, got a lot of thanks, and especially to start with Jim Lindquist, who's been with this study a long time, and I've really valued his contributions to Jackson and to Redwood Forestry. Green Diamond Resources was enthusiastic enough about these plots that they came back and remeasured them. They did the stem mapping, which added a lot of value, including figuring out the exact dimensions of those plots and changed some of our math. And lastly, Jeff Letty, our biometrician, who helped me with the volume compilations. If you missed Pascal's presentation where he talked about the AI index, that's the reference if you want to delve into that. And we'll be going over some more of that in the written proceedings. Questions?
Lynn, I may have missed this, but did you say how old the stands were when they were treated, and have they only been treated once?
Oh, yes. Oh, that's a fair, yeah, I'm sorry if I missed that. I may be having my own timer going too fast here. The stand was 17 years old when it was thinned, and the last measurement was at 49 years. So we definitely, especially in the lower densities, there are, quite a few, you saw that there's quite a few merchantable stems out there at this point, but there's other dynamics that are going to be really interesting to look at. Okay. Thank you very much, Lynn. Awesome.